Hello, my dear students. My name is Lakshmi. This is Ellen brand of chemistry. Today, in this video, we are going to discuss about chemical kinetics chapter. So, chemical kinetics from the starting onwards, from the introduction onwards, we will discuss. So, first of all, what is chemical kinetics? Chemical kinetics is one of the branch in physical chemistry. It deals with the study of rate of reaction, reaction mechanism, and factors affecting the rate of reaction. So we can write that is chemical kinetics, one of the branch in physical chemistry. It deals with study of rate of reaction. This simply we are calling ROR, rate of reaction. Then factors affecting the rate of reaction. Factors affecting the rate of reaction. Rate of reaction. Third one, reaction mechanism. Factors affecting the rate of reaction and reaction mechanism. Look at my dear students. The chemical kinetics, it is one of the branch in physical chemistry. Then chemical kinetics, what it deals, rate of reaction, factors affecting the rate of reaction, and then reaction mechanism. So generally, one of the physical chemistry topic, that is thermodynamics, is there. The thermodynamics, it deals with the study of feasibility of chemical reaction, whereas chemical kinetics, it deals with the study of rate of reaction and also factors affecting the rate of reaction. So that point also you have to note it. Thermodynamics deals with the study of feasibility of reaction, or whereas chemical kinetics deals with study of rate of reaction and also factors affecting the rate of reaction. So here, before going to discuss about the rate of reaction, first, based on the velocity of reaction or speed of reaction, chemical reactions are three types that we have to discuss. So remember, based on velocity of reaction, or we call it as a speed, or speed of reaction, chemical reactions are classified into classified into three types. How many types? Three types are there. So what are those? So what are the examples for that particular reactions that we have to discuss? So what are those? First one is very fast reactions. Or we call it as instantaneous reactions. Very fast reactions are instantaneous reactions. Number one. Instantaneous reactions. So what are the very fast reactions or instantaneous reactions? The reactions The reactions which can takes place in fraction of seconds are called very fast reactions. So ये reactions are which reactions very fast within the fraction of seconds that takes place. Such type of reactions are called instantaneous reactions or very fast reactions. Sir, what are the examples for the very fast reactions? So example number 1, precipitative reactions. Precipitate reactions. Sir, what are the precipitate reactions? So one of the example for this, in case AgNO3 solution, if you take, when it is treated with NaCl, aqueous solution, even this is also aqueous solution. When it is treated with the NaCl, then it can form AgCl. It is one of the precipitate. PPT will be formed plus NaNO3. So such type of precipitated reactions, the very fast reactions. Next, one more example for the very fast reactions are neutralization reactions. Neutralization reactions between strong acid and a strong base. In between the strong acid and strong base, neutralization reactions, whatever it is there, that all are very fast reactions. Third one, combustion reactions. Combustion reactions. Combustion reactions are nothing but reaction with hydrocarbons, reaction with oxygen. Hydrocarbons reaction with O2. These are also very fast reactions. Then one more example for very fast reactions are explosive reactions. Explosive reactions. So explosive reactions, explosive of TNT. These all are very fast reactions. Note, remember, very fast reactions, whatever it is there, we cannot determine the rate of reactions or such type of very fast reactions. Cannot determine rate of reaction for such type of very fast reactions. So these are very fast reactions. Very fast reactions ki manam rate of reaction ni find out cheyaleem. Next reactions are very slow reactions. Slow reactions. What are those that we have to discuss? Very slow reactions. Second one, very slow reactions. The reactions which can take place. Very long period of time. Are called very slow reactions. Examples for the very slow reactions are rusting of iron. Iron rust avadam. This will take months or years also. So rusting of iron, that is one of the best example for very slow reactions. So chemical reaction for the rusting of iron is 4Fe plus 3O2 plus X moles of H2O. Then when it is involved in the reaction, so iron, oxygen, water. So water, it is in the atmosphere, water drops, whatever it is there. So that is 2Fe2O3, then XH2O. This is rust. Remember, they will ask a formula also, rust. So rusting of iron, one of the example for very slow reactions. So number 2, reaction between hydrogen and oxygen at room temperature. Room temperature దగ్గర rate of in between the hydrogen and oxygen reactions are very slow. Then third one, reaction between carbon monoxide and hydrogen at room temperature also very slow. Then fourth one, reaction between carbon and oxygen at room temperature, it is also very slow reaction. Remember, all these reactions are very slow reactions. Even very slow reactions, for very slow reactions also, rate of reaction we cannot determine. Remember, note for very slow reactions also, rate of reaction cannot be determined. The next, third one, that are moderate reactions. What are the moderate reactions that we have to discuss? So ippadi very fast reactions and very slow reactions we are discussing. Now we are discussing that is moderate reactions. The reactions which can take place in measurable time. Are called moderate reactions. So what are the examples for the moderate reactions? Example for the moderate reactions are then hydrolysis of ester. Example, if you take CH3 COO C2H5, it is one of the ester. If you add water H2O in the presence of Ha plus, then it gives CH3COOH plus C2H5OH. Then next, one more example, inversion of sugar, that is C12H22O11, cane sugar. Sir, even for the cane sugar, if you add C12H22O11, if you add water in the presence of H plus, then even it can give 2 moles of C6H12O6. Then third one, that is hydrolysis of ester that we are seeing. Just wait. Yes, third one, look at decomposition of H2O2. So H2O2 on decomposition, it gives 2H2O plus O2. Then fourth one, decomposition of N2O5. Then one more example, iodination. Fifth example, iodination, that is haloform reaction. We call haloform reaction of propanone, that is CH3 C double bond O CH3. This is propanone, right? When it is treated with iodine in the presence of a base, NaOH or KOH, then it will be converted into CHI3 iodoform plus then CH3COONA. So look at, so all these reactions are moderate reactions example. So many other is there, that you have to remember. Hydrolysis of ester, inversion of sugar, decomposition of N2, decomposition of H2O2, decomposition of N2O5, the haloform reaction, all these are moderate reactions. Sir, for very fast reactions and very slow reactions, rate of reaction cannot determine it. But for moderate reactions, we can determine the rate of reaction. So that is why we have to discuss what is rate of reaction. The rate of reaction ante enti that we have to find out, which is rate of reaction. What is the rate of reaction? We have to find out. We have to discuss rate of reaction. Rate of reaction. First, write the definition. Rate of reaction. Rate of reaction can be defined as the change in concentration of reactant or product, concentration of product per unit time. This is called rate of reaction. Rate of reaction ante enti? The change in the concentration of reactant or product per unit time is called as rate of reaction. So rate of reaction, it is equals to change in concentration of reactant or product time taken for change. This is rate of reaction. So rate of reaction ante enti? For example, in case A gives rise to B, this is one of the reaction. So the concentration of this, so the initial concentration when time t equals to 0, then just assume it, the 100 molecules will be there. Then B, 0 will be there. So time is taken something, 10 minutes or t1 minutes. Then concentration will become decreases. Reactant concentration decreases. Reactant concentration, when it is decreases, in the same time product concentration increases. So in case if you take some more time, T2, then some will be decreases. The some more time, at last end of the time, in case if you take, the concentration of A becomes 0. Then concentration of B becomes maximum, the 100, like this. So what happened there? Change in the concentration of reactant decreases by change in the time. Time change అవుతూ ఉన్నప్పుడు concentration of reactant decrease అవుతుంది. అలాగే concentration of product increase అవుతుంది. So we can also define the rate of reaction. Rate of reaction can be defined as change in the concentration of reactant, nothing but decrease in the concentration of reactant or increase in the concentration of product. Decrease in the concentration of reactant or increase in the concentration of product per unit time. Per unit time is called rate of reaction. Rate of reaction. We can also define like this. So what are the units for rate of reaction? Rate of reaction ki units enti? That we have to see. Units for rate of reaction. General ga rate of reaction ela define chesam? Rate of reaction equals to change in concentration by change in time. Nothing but concentration units are what? So in case if you take molarity, concentration term molarity, mole liter inverse. Then change in the time units are seconds. The finally mole liter inverse, second inverse. These are the units for rate of reaction. Rate of reaction units ఏంటి? Mole liter inverse, second inverse. Sir, in case, if you take for the gases, for gaseous reactions measure చేసేటప్పుడు rate of reaction is equals to change in the concentration, not change in the pressure you have to take. So change in the pressure, change in pressure, change in time, change in time. So in the place of mole liter inverse, we have to take it as, sir, atmosphere, then second inverse. This is for gaseous reactions, this is for then aqueous solutions, whatever the examples we are taken for the moderate reactions, you know. So for the moderate reactions, that is. So these are the units. So now when we are expressing the rate of reaction, we have to take the formula, that is rate of reaction equals to plus or minus, so change in the concentration divided by change in time, or change in volume divided by change in time also you can take, or change in number of moles divided by change in time. So all these terms we can use by calculating rate of reaction. Remember, so change in concentration divided by change in time, change in volume divided by change in time, change in number of moles divided by change in time. So then one more point we have to discuss here, that is, in case positive sign is there, this sign is used when products are considered. Remember, products కోసం అయితే పాజిటివ్ సైన్ ఇచ్చేస్తాం. సో నెగటివ్ సైన్ ఈజ్ యూజ్డ్ ఫర్ when reactants are considered. So note it all this. Next, one of the most important point you have to remember, that is, for any reversible reaction, concentration of reactants are decreases, and at the same time concentration of products increases. Note, for any reversible reaction, concentration of reactant decreases, concentration of products increases. Now only we are discussing, that is how increases. Sir, in case if you take reactant can be converted into product. So I told when time t equals to 0, reactant molecules are 100 is there. When the time progress, then that will be decreases. Which is decreases? Concentration decreases. And at the same time, when product concentration, when time t equals to 0, time 0 ఉన్నప్పుడు reaction start అవ్వక ముందు product concentration 0. When time progress, concentration of product increases. Finally it becomes maximum. So this is for irreversible reactions. In case graphical representation, if you take, so first one with respect to reactants, if you take, I told that in irreversible reaction, concentration of reactants, what happens? Decreases. So now if you take graph in between the concentration versus time, concentration of what? Reactants. What happens? Decreases, I told. Concentration of reactants decreases. Yes, concentration of reactants decreases. Then in case products, if you take concentration of products, what happens? Sir, first starting at 0, Product concentration, what is the 0? But when time progress, then it will be maximum. It will be maximum. So this is for reactant curve. This is for product curve. Remember, so rate of reaction graphically we can represent like this. For the reactant decreases, product increases. Then this is noted just. Then we'll discuss the types of rate of reactions.